Computer. Okay. Okay, so we're recording? Yeah, great. So I just want to hide this and let's go. Okay, so please, no one's, I don't want to have too many volunteers to present. I think it's a good idea. You get a pretty good grade. So,
Oh,
what?
you're talking to me?
No, everyone, the people on Zoom also. Okay, so let's go. So today, we're going through the rest of the um, we're going through the rest um, of the what's the word? The uh, the object-oriented principle. So let's just go. So far we've done. Let's see which ones we've done. So. This is the documented. This is the document of the object-oriented principles. So, so the first four we did already, right? You all recognize those? The first four? Encapsulation, what?
Yeah.
Encapsulation, abstraction, inheritance, polymorphism. Then we added from the strategy pattern, we see that we prefer composition over inheritance. Right? We don't like inheritance because it's too tight of a relationship. So, so that was number five. And then six was we don't like modifying code, right? So we rather make code in such a way that if we want to change something, we add more code rather than modify existing code, right? We rather create new classes for new behavior. So that was like, we did that like with the duck, different ways of flying, if you remember. Okay. So, um, okay. Then we said there's solid, which stands for single responsibility principle. O stands for open close principle. L, whatever, we're going to go through them. So these represent five more principles, okay? So if you go for a job interview, they might say, what are the solid principles, right? So first we have the first four, which are very well known, right? And then we have the solid, which are also really well known, okay? So let's go look at the solid ones. So the solid, the S in solid stands for single responsibility principle, which basically we did last week. And the basic idea behind that is, and I'll show you, is that it's not good to have um, a method that does too many things. So, for example, over here we had we had a method called create and print. But if you look at it, it does like a lot of different things. It could print, it could create only, it could print and email. So it's a very complicated um, a code, right? So the single responsibility principle says, wait a second, this thing is doing three different things, right? It's really, we should really actually call it create, print, and email, right? So I got to fix it up over here. So it should say and email, right? So this is doing three different things and it's kind of confusing, right? So if you look at this code, right, you know, it works, but I mean, I think it works. I didn't really test it, but it should work, except it's kind of confusing, right? And imagine you have to make a change to this without breaking anything else, right? Be very, very difficult, right? Because of all the conditions it does, right? So, so instead, we said, it's doing three different things. So let's just break it up into one method that creates a statement and returns it, one method that prints, and one method that emails, right? Actually, I should probably pass this a statement as a parameter, print statement, and then, yeah, so it should be um, whatever, and then we should have email, we pass it the statement. So now it's much simpler, right? We split it up into, and we split this up into, um, I think over here I have to, uh, I just have to pass this in probably. Okay, whatever, it's not important. The point is that it's when we hit this code over here, where it's split up into three different, um, oh, actually, I don't need these parameters. I take that back because it's part of the statement, methods. It doesn't have to. I take that back. Okay, so let's get rid of that. Okay, the point is that when we split it up into three different, we have three different methods that only do one thing. What is it effectively doing? We're doing the single responsibility principle, right? We're doing only one thing in each method. This method is printing, this is emailing, and this is creating a statement. Okay, so we split it up. And instead of this mess over here, we have this code over here, right? So we don't have to have one method doing three different things. We rather have three different methods doing only one thing. So that's single responsibility principle. That's from last week. Okay, today I'd like to do, I want to skip, okay, let's do Liskov substitution principle. Okay. Now, Liskov happens to be a lady, and her first name is Barbara Liskov, and she's actually a professor in MIT. And so if you could, she's still alive. I think where is this? I don't know why it went there. So if you could look her, you could see a picture of her. Barbara, I gotta change my glasses. So So actually, this is what she looks like now. She's in, I think, MIT. So, so that's her. So yeah, there's a Liskov substitution principle, which is named after her. Um, it's the only, uh, it's the only um, person that I know who has a principle named after them. So I'm not sure why she managed to get it named after her, but we'll look at what a principle is. Okay, let me just change my glasses. Uh, I really need bifocals. I have to get them. Okay, here we go. Okay, so what is Lipscott's substitution principle? So let's look at over here. So let's imagine this is a famous example of the Liskov substitution principle, okay? Just like if you go for a job interview, there's like something, they would teach you. So let's say, for example, you have a class called rectangle, okay? And a rectangle has what? Four sides, right? But um, so it has a length and a width, right? And let's say initially, let's make it equal to 1. Why not? It doesn't really make a difference. And then we have an area method, which, let's say public, and this returns an integer, and it's basically it's going to return multiply length times width, right? So we return length times width. Okay, so this is our rectangle, and this is really supposed to be private, and we're going to um, generate some methods, the getters and setters for both of them. And let's put them over here. So far, pretty simple, right? Okay, so we could um, we could go over here. We could, for example, we could create um, a um, a rectangle, um, new rectangle, and then we could say rectangle dot set width to be, let's say 5, 4, whatever, and then rectangle set length to be 5, and then we could print out the rectangle uh, area, and we could say the area is, and then something like this, right? So we could go over here, we could print it out. Oops. Yeah, thank you. Yeah, it's gonna, maybe it'll work. Uh, yeah, I gotta run it again. Okay, so it's gonna have the area. Whoa, what's it doing? Yeesh. Okay, the area is 20. Okay, so it worked correctly, right? So it, okay, so now we say, wait a second, this works so well, I want to create another class called a square. Now, if you think about it, a square is really a um, it's really a rectangle, except that the sides are all the same, right? So it's a form of a rectangle. So we could do extends. So this extends rectangle. And the only thing is the sides have to be the same. So for example, we're going to call, so we say set length or set width, right? So over here, over here, this is basically super means, does everybody know do you understand what it's doing over here? When we call the set length method in square, it's calling the parent's set length, right? Because there's no, because square doesn't have anything, right? Inside of it the variable for the length and width is inside here, right? It's over here. So in order to get hold of it, we have to call the the base um, class, right? So that's what we're doing over here. But they have to be the same, so right, in a square. So what we're going to do is this is going to be the they both have to be the same size. So this is what we're going to copy the set length over here. And this, so every time we change one of these, right, we're going to change both of them, right? Because they both, the length and the width have to be the same for a square, right? So if we go back to our class over here and we, let's say we, instead of doing, now remember, a square inherits from rectangle, correct? So is square a rectangle? It is, right? Why? Because inheritance it is called a relationship, right? So a square is a rectangle. Okay, so we have to, so therefore, it's legal for us to write over here square, right? Because the rectangle is on the left, but since it's the parent of square, it could point to a square, right? Okay, right? So now when we run our code, we okay, let's see what happens. Oh, wait a second, we just got a different value. It's because set length over here is, oh, it's not really calling, it's really calling this this set length, which is setting both the length and the width to be 5, right? So the last value over here is going to be set to be every time we call one of these for a square, right? What happens? Both the length and the width are always going to be the same, right? So for example, over here, it's going to be 16, right? If we run it, right? Because it's always going to be the same, right? So, so we're never going to have, so we're always going to get, we're going to get a different result sometimes if, depending on what's on the right side, right? So this is an example of where the child class gets a different result than the parent class, right? Because if this would be a rectangle, right, the result would be of 20, right? 4 times 5, right? But when we put the child here, right, we put the square over here, now we're getting a different result, right? For the same, it's none of the code on the left has changed, right? It's still the exact same code, but we're getting a different result, right? So this is called, um, I wish I knew how to turn off um, the waiting room. Is there a way to do that? Uh, 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 sure.
This window,
What?
using this iCal, I mean like this.
How do I turn off the waiting room? Should be under here, right? Under participants. It should be one of these, I think. Uh, yeah, it's turned, I don't have the right to it. Yeah, yeah, okay, yeah. I just have to let people in. Okay, so, um, that's what I pay for not using my own. Okay. It's just I refuse to pay Zoom money because they keep raising their rates and they don't give you anything. Yeah, it's yeah. I could use Google Meet for, for half price. Anyhow, so um, I think it's called Google Meet, right?
Yeah.
Yeah, Meet. Yeah, so it's cheaper. And anyhow, so that is the Okay, so this is the Liskov substitution principle, which says that if you imagine that, in other words, let's say someone wrote code, right, which takes a rectangle and expects a certain, calls this method and expects a certain result. And all of a sudden, I pass in the child, right? So I would expect the same result. So she says that if the child should never give a different result for the same method as the parent. In other words, if the parent object will give if you use that object, you get one result. You shouldn't have a child object, which returns, if you call the same methods, will give a different result. Okay, that's the Liskov substitution principle. Okay, so I read over here, it says if a parent class returns a certain result, then all of its children should return the same result for the same method, right? For example, I wrote the area method in square must return the same value as rectangle. The couple is broken. Like, so for example, over here, if we pass in a square, right, we're going to get a different result, right? For that, for example, right? Right, if we would call this code and depending what we pass in, we would get a different result, right? We passed in rectangle, we get one result. If we passed in a square, we get a different result. But this code should always give the same result, right? Okay, that's the Liskov substitution principle. It's a very complicated name for something pretty, it's not so complicated. Okay, so um, okay, next, let's do one more principle, and that is called okay, again, it's a very big name. It sounds complicated, but it's not so complicated, really. It's called the dependency inversion principle. Okay, so let's take a look over here. So let's say, for example, we have a account and I'm sorry, we have a database object. Um, let's say, actually, let's have it SQL Server database object. And let's say this has a method called public void store, and it's going to we pass, let's say, money. Maybe we pass it a account number. Um, and we store this amount of money in the account, right? Okay, so we store some money. Okay, so we'll say saving money to account and then plus and then we'll do the account number. Okay, right. So we're basically okay. So we're going to save the money to the account number. Let me put that in one line. Okay, so this is our object, and then we have an account where like let's say a checking account. in our checking account, has a, void, I'm sorry, has a, let's say balance. And then I spelled that wrong. Balance. And then, whatever that is. And then I have a method called, let's say it to be private. And then let's say we have a public method called deposit. And then we do double money. It should just be a double also just to be same. And then we just do, and then we say that balance plus equals to money. Right, we add the money to the balance, and then we call this SQL Server database object. And then we call database dot store, and then we store the money. I'm sorry, balance, the new balance, right? Oh, we need an account, checking account. Let's say it has a private and account ID. And then we are going to save to this account this balance, right? Okay, so this is our code, okay? So, okay, so now let's look at this a little bit better, okay? So if we look at this, is what is SQL Server database, this object over here? Could you see it, by the way? Yeah. What is it dependent on? What does it need? You know, it it really kind of it doesn't really need any other objects, right? I mean, it needs the it maybe needs the it knows it has to be able to print, but that's whatever. But it doesn't. It's not dependent on any other object that we created, right? It just uses the objects that come with Java, right? But checking account, is checking account have any dependencies? Does it require anything? Well, yes, it does, right? Because if if it's dependent on SQL Server database, right? Right? So in order for this to work correctly, it needs this object, right? So the way you would draw it would be that and I'm not good at this, but let's just say we go to Paint and uh, let's say, right, so the way you draw it would be that you would have, let's say, um, you would have, let's say, on the bottom, you would have the SQL Server database, why is it at the bottom? Well, why, it's at the bottom because there's nothing dependent on it, right? Right, could you read that? Or can make it bigger? Yeah. So at the bottom, you have this database object, and then on top of it, you would have the things that's dependent on it. So on top of it, we would have I said, what is that? Oh, wait a second. Oh, I can make someone else the host? It's okay. There's there's no there's no one in the waiting room. I could see sort of. I don't think anybody's waiting. Are there? No, it's okay now. But maybe it's a good idea. for the future. Yeah, so, um, okay, so, um, oh, you're back to here. So I do over here, I do, is the checking account. And, and this has a dependency over here, right? So I think I go from here like that, right? So checking account is dependent on SQL Server database. So the way you draw it would be the thing that has the least dependencies is at the bottom, and the thing that's dependent on it, sort of like it's built on it, right? So that goes on top of it, right? Sort of like a building, right? That you can't build the first floor, a second floor, unless you have a first floor, right? So the first floor, the second floor, you could build the first floor without the second floor, right? We could have the SQL Server database without a checking account, but we can't have a checking account without the SQL Server database. So if you think about it, it's sort of built on top of it, right? So that's why the SQL Server database goes at the bottom and checking account goes on top of it, right? Because it needs the layer underneath it, right? Okay. So so far so good, right? So now we have a checking account over here, and it's dependent on a class that's underneath it, right? And we have database, which is on the bottom because there's nothing underneath it. It doesn't require anything underneath it, right? So, okay. So what's the problem with this? The problem is that the way we created it is that, let's say my boss would come to me tomorrow and say, you know what? We're thinking of using a different type of database, right? We want to use Oracle. Have you heard of Oracle?
yeah.
Yeah, they own like everything, right? It's like what's his name? Ellison? I forgot his name.
Bought this Chinese app as well recently.
I think he owns OpenAI, I think.
No, he owns TikTok now.
Yeah, he owns
Yeah.
TikTok.
Oh, but I think he also owns OpenAI. I think he owns a lot of things.
Yeah.
He's like a rich guy. No.
Uh,
What?
he owns the government, like all the CIA, API, like he can all the data and then it shows.
Okay, yeah. So yeah, I don't even know how he got so rich. Like I mean, I guess Wall Street uses Oracle. Um, but I don't know anymore if they still do. But like when I was first started programming, like anything financial would use Oracle because it was very fast. It was extremely fast database. But they weren't the only database around. I mean, but
Might be wrong, but I heard like over 3 billion devices are using Oracle
3 billion.
devices. Or
He-
like in different companies or like different things and
He-
apps, so like they're using one way or another, and they're using in Oracle. So
Oracle database?
I mean, like
Uh-huh.
the service that they're providing when it comes to data or like
Uh-huh.
software.
Yeah, because now they own lots of things. He bought um like at work we use something that they own. It's called some accounting software. So they own a lot of they own more than just but I think originally it was just a database, right? I think they own Java also, right?
Yeah.
Yeah, so but but they give it out for free. I don't, and maybe they charge for it. I don't know. But anyhow, somehow he became really rich. Yeah, I don't know what he bought. So, because like Microsoft, I could see being rich because Microsoft is like, um, everywhere, all over the world. Every computer has it, Windows. So, but Oracle, like, like why are they so big? Like, you know, so, um, Also could be that maybe he kept all the shares for himself, so he became rich. Like instead of Microsoft, like they gave the employees a lot of it. I'm not sure. Anyhow, somehow he became very rich. So, uh,
Into internet, involved in, like, let's say right now, so he owns TikTok. So I think like all these years, I mean, like, I mean, which stock to buy or how to keep it. So right now, I mean, he has like the biggest stock, which is like, I mean, TikTok, right?
uh,
Like,
he figured out what to buy. Okay, he made good investments. Okay. Um, there's a guy who's now, I think, he was running for president as a Republican. I think now he works for Trump, and he was a governor, and he wrote the software that our company uses right now for accounting, and we're getting rid of that. But then he sold it to Microsoft. So, and then our new accounting software is Oracle. So yeah, so the um, anyhow, but I remember Oracle was very hard to use. It was very difficult to use, but it was very fast. Much was like the fastest database. So for Wall Street, that was really good. Yeah. It was expensive, but it was fast. Um, so maybe also had a lot of it was complex. It wasn't just a toy. It was more like a real business solution. Anyhow, so let's say my boss says, you know what? We need to let's say SQL Server isn't really that good. We need to, I don't know. You pick your database. Snowflake. You ever heard of Snowflake? That's a type of database. Uh, it's a like an AI database, I think, right? I haven't really used it, but I've heard of it. Snowflake. It could be does maybe uh yeah, Data Cloud. So there's I don't know. There's also Snowflake. And I think which database does Amazon have? Amazon.
yeah,
Yeah, AWS. What database do they have? Uh, Data Lake, is that it? Is they have a yeah, I know what they have. Uh, wow, they have a bunch of databases. Okay. Uh, they have oh, Aurora. Okay, they have all, and then they have the other ones. Okay, I think, but that's the one they use. They have Aurora. Okay, so. Anyhow, so that's the one they use. So let's say somehow my boss says, you know what, we're going to the cloud and we don't want SQL Server, right? We want to use, I don't know, something Aurora, right? So we say, uh-oh, look at all this code over here. It's dependent on SQL Server database, right? And this is, imagine a real application. You could have thousands of objects accessing this this object, right? So what are you going to do, right? You're going to change go through every single object and change it? Well, we in this situation we would, right? So if my boss says we got we were changing databases, then we're kind of in trouble, right? Right? So what would make this code more um, less more easy to modify to make a change? Or maybe not, we wouldn't even have to change it, right? Right? And and what is the problem, by the way? The problem is well, there's a bunch of problems, um, but one of the problems is that um, there's a dependency between checking account, right? All these objects are dependent on database, right? And database is SQL Server database is underneath it. If we could somehow So this is what the dependency aversion principle says. Forget about the words, okay? It says, don't rely on some concrete object, which is, which if that would change, then all your code would fall apart. Rather, let's think about it a different way. Let's create a interface, okay, called database. And then database will have a method called store. If you don't need the public part if you're an interface. And right. And instead of having SQL Server database in this code over here, instead we could maybe pass it in as an interface. So maybe we could have when we create checking account, well, let's create the interface. Okay, so now we could do is when we create this object, we could pass in the interface for a database, and then we could get rid of this code over here. So in other words, right? So now what do? We said instead of depending on an object that was beneath us called SQL Server Database, now we're relying on this interface that if you look at it, oh, I'm sorry, did we have to do one more thing? We have to do over here, we have to have this also implement the database. Right? So now look what happens. Now database is dependent on both. In other words, instead of where were we? Instead of checking account being dependent on SQL Server database, which was underneath it, it's dependent on the database interface, right? And so is the the SQL Server database. It's also now dependent on that interface. So basically, what we did is, if we were to draw it a little bit differently, so now we did was I do a new picture. So this would be save as this would be where is it? Where is it? Come on. Okay, this is before before uh, um, before dependency inversion. Okay, so this will be before, and let's do after. Okay, so let's make it an after. We would have this is how it would look. It will look. So we have no, that didn't work. Why did not good at this. Oh, here we go. And here we go here. Oops. Here. And then we go here. So now on top, we're going to have database, which is a um, eh, or whatever. And then over here, we have checking account. And we have a SQL Server. Right? And both of these, so now checking account is not talking to something beneath it, it's talking to something above it. So this is, they're not talking directly to each other. Okay? So why isn't it drawing? Because it's not black? Oh, just it's white. How do I change its color to be black? Uh, oh, I go here, here. Okay, so go here, here. And so now checking account is dependent and SQL Server database are both speaking to the interface above it, right? So checking account doesn't know anymore about SQL Server database, right? Rather, and SQL Server database doesn't know about checking account, right? Well, it never did, but now it knows about database, right? So, and also if we add Oracle, right? We could add Oracle over here and um, maybe put it somewhere else. Let's do Oracle over here maybe. And then if we add Oracle, it could also be dependent on database. So now we have all these different things and they're all dependent on the thing above it, right? Which is called database. So therefore, we could theoretically go back to our code and we could have another, we could take this code over here and create a new object called Oracle. And then put this over here. And now we could say Oracle. Right. So now we could have in main, when we do our checking account, let's just comment this out for a second. And we could have our checking account equals to new checking account, and we could pass in, we could pass in SQL Server database, right? And then we could do, or we could, um, right, or we could pass in, why is this giving me equals new? Oh, what did I just do? Uh, or we could do the same thing and we could pass in Oracle. So checking account 2, and we could pass in Oracle. Right? And we could do checking account 2 dot deposit, and then we could deposit $100, and then we could have checking account 1 would deposit, let's say, $1,000. So the point is that so the point is now, without changing any code, checking account could use either database, right? We could get rid of this part over here, and now whatever database we pass into it will work. Okay? And so we don't have to go through thousands of objects and change the code, right? Well, because we instead of relying on a concrete object, right? Depend on a concrete object. Instead, we're like our dependency looks like this. We have database above us, and we're all speaking to the same interface, right? So when we do it this way, now we don't have to rewrite our code every time we change our database, right? That's the idea. Right, so over here we're writing to SQL Server, and here we have the exact same code, but saving it to Oracle. Okay? So that's the idea behind dependency inversion principle. And the reason why it's not important why it's called dependency inversion, but the idea inversion means to flip it, right? So in the first one, well, let me save this. This is after. After dependency inversion. So before we started, remember SQL Server was underneath checking account. Remember that? Remember this was our picture we started with? We started at SQL Server was on the bottom, right? But now underneath checking account. And then after we moved it, we moved SQL Server to be the same level as checking account, right? And we did that by making everybody speak to one interface. Okay? So Oracle, SQL Server, checking account, they all speaking to this database interface. And by doing that, right, we don't have to rewrite the code every time we change our database. Okay? This is a very good example. It's also realistic because nowadays, right, we're always changing our as new databases come out, right? Right, you're always, you're always interested in, different database, right? But so you don't want to have to keep on rewriting all your code every time you change your database, right? Um, and also theoretically, you could use the same code with different databases, right? You also, like if you study databases, there's there's actually three different types of database. Um, there's the regular. Oh boy, I'm trying to remember this. What are different database? No. It's like a higher level type of database. Wait a second. There's like a I forgot them. There's OLTP, I think, database. So this is like basically what we think of as a database. Basically, when you go into Walmart, you buy something, right? That would be a OLTP, meaning that it's doing transaction processing, right? So basically, the idea is that we're not trying to like you want it to be real fast. You're not going to run a report that takes an hour on an OLT database, right? Because while people are trying to check out at the checkout counter, you're not trying to run a report on that same table to see how many bottles of ketchup were sold, right? That wouldn't make sense, right? Because then you'll people won't be able to check out at the checkout line, right? So there's another one called the OLAP. What?
Yeah.
OLAP, right. Is another one, right. So OLAP is for if that's like you would basically it's basically designed for this analysis, right? Right? It's not so much it's basically it's like the database is like made for like slicing and dicing, right? It's called dimensions, right? So you want to analyze the data and look for, like how many people bought ketchup on Sunday uh, who were who were under 20. You know, if you want to ask a question like that, so that's designed for those type of questions, right? So it's a special form. It's made for those type of questions. And there's one more, which is Elastic database. Oh, that's what it's called. There's Elastic database, which is, I'm not sure what the difference between Elastic search. Oh, it's made for searching. Um, uh, I'm not sure if it's different than an OLAP or it's a type of OLAP. Okay, but what?
The third,
Yeah, Elasticsearch. Is that a different type or is it like a type of OLAP? But um it's made for searching, right? So I'm not sure if it's the exact same thing as OLAP, but it's made for like when you want to do searches and you want to get quick results. Okay. Um, so it looks like the main thing it has is a lot of indexes. Uh, Yeah, so those are the three that I know about. So basically, so you might want to change your code to use, instead of using an OLAP, like let's say you want to, without changing your code, you said, wait a second, this what I want to use is the wrong database to use it for, right? Say, well, I want to run, let's say I want to run a report and I'm using a transactional database, right, which it can't be tied up, but I want to run, let's say, a daily report. What do I do? Right? So I can't run it so what banks do is, I think they do all this stuff at night, right? Like they do all their processing, all the tables, they do it at night, right? Like in the middle of the night, they they shut down the database, and you can't do anything for like an hour, and then they do all the data or whatever they have to do, or if they have to do reports or something like that. So you would run the report like early in the morning when no one's around, very few people are doing anything. But that only works if you're like in one country. But let's say you're international, then there's no evening, right? So, but that's like I think before they came up with the idea of having different databases with the same data but different formats, right? So what you would do is you would use the same database but at different times of the day, right? When things weren't busy. But nowadays you would actually use different databases, right? Okay, so that is the, so basically that is, we did today was we did um, the, we did um, the, um, the L for Liskov, and we did the D for dependency inversion principle. Okay? And I guess we'll just finish up on Thursday. We'll finish up with uh, the rest of them. Okay? But there's not too much left. Okay?
What is the bit?
The midterm, we, uh, we look over here.
I think it's 19.
Oh, let's find it. It's on, is a folder called schedule. And it looks like it's for the 19th,
Oh, sorry.
24th. Yeah. Okay, got me scared. Okay, don't scare me. What's today? Today is wow, it's already March. Isn't that crazy?
Views on.
Yeah.
That's what-
Yeah, we have a while to go. Yeah, and I have a practice midterm for you guys to work on. Yeah. Okay. So, okay. Oh, wait a second. I'm going to be absent one day. I'll have to make it up. Uh, yeah, I'm probably gonna be absent, was it March 5th? I think I'm gonna be absent March 10th. I have to check. I'll let you know tomorrow, okay? Uh, oh, wow. Okay. Yeah, I probably won't be at one of class on March 10th. I have to ask my wife to make sure. I have like we have a family thing I have to attend. So, okay. So, I'll have to miss that class. Um, yeah, so what we'll do, oh, we'll see. Okay. We'll see what we'll do exactly. Maybe I'll move the midterm to Thursday. Does that make sense? I don't know. Okay, we'll see. Sh- Uh, I'm probably going to be probably no class. Okay. So, okay. Um, um, okay. Okay. So I'm pretty sure I'm not gonna be here then a week from today. Okay. I have to check with my wife, okay? So, okay, so I'll see you guys and see you on Thursday. We'll finish these up and then we'll move on chapter 3, okay? Chapter 3 and a little bit stuff to do with UML diagrams, okay? We already did a lot with UML, but I want to do a little bit more with class diagrams, okay? And then we'll have the midterm, okay? Okay, see you. And you gotta plug my thing in. You can, yeah.
So the exam is gonna be a multiple choice or it's gonna be for different time?
It's going to be,